So today's talk is explaining data-oriented programming to non-Clojurians. Our speaker today is Yehonathan Sharvit, and he's well known in the Clojure community. Actually, I don't know if you remember this, but we go back pretty far when I was asking you for help about your Clips system, and I was using that for some blog pages. Clips is, I think, very widely used and enjoyed by people. So that's been a great contributor to the community. And now we have your book, Data-Oriented Programming, Unlearning Objects, that has hit, or it's in a preview edition, correct? Is that correct?
Yes, it's kind of an alpha version.
So that's
early access program.
And you can talk a bit more about that if you like later on. But for now, let's start the presentation, and please take it away, Yehonathan.
Okay, thank you, Mark, for the introduction. Again, it's really a pleasure to be here in the Boston Clojure Meetup. And really, it's one of the gifts that we got as humanity from the COVID, that we can connect even though we are very far away. I don't think that 2 years ago, somebody would have thought that, or me, that I will be able to give a talk at a meetup in Boston from Israel. So that's a good thing we got. We got lots of bad things, but we got also some retribution. So today I'm going to talk about data-oriented programming, the secret sauce that makes Clojure systems less complex or simpler. My name is Yehonathan Sharvit. On Twitter, you can find me under this handle. Viebel is a shortcut for life is beautiful in French. A few words about me so that you know who is the person that says so many silly things. So I've been a developer for around 20 years. And for me, there is really before Clojure and after Clojure. So until 2012, I think I was an okay programmer, but I didn't have lots of fun programming. Even I think I was struggling when programming at work, and I was not programming not at work. And one of the reasons is that I had this feeling or this impression that I always had to make the compiler happy. I was programming in C and C++, and I was wasting so much time trying to convince the compiler to do what I want to do. And I had not enough time to express the content of my winning. I was dealing with the syntax and the problems, the low-level stuff, and I couldn't express the business logic. And it started to become easier for me in 2009 when I discovered JavaScript. And I really think that JavaScript is a great language to express yourself as a programmer. The fact that it's dynamically typed, the fact that functions are first-class citizens. It's really amazing, and it makes such a difference programming in C++ and programming in JavaScript. And it was only 3 or 4 years later that I understood why. That in fact JavaScript is really in the spirit. It's a Lisp. And I don't know if you know the story. The guy that made JavaScript in 10 days, the famous Brendan Eich from Netscape. His idea was to make scheme in the browser. And just in the last minute, the people from Netscape told him, if you go with the parenthesis syntax, nobody will use it. So please make it look like Java. But really, in the spirit, JavaScript has a lot in common with Lisp. And for me, 2 things are really impressive in JavaScript. The first one, remember, JavaScript was invented in 1995. It 25 years ago. The fact that functions are first-class citizens. And the second thing is that data also is first-class citizen. The fact that you could put a JSON object everywhere in the language with the curly braces or arrays. Back in 1995, it was a revolution. So in a sense, JavaScript is a data-oriented programming language, you could say. We will see during the talk what is missing from JavaScript to be a fully data-oriented programming language like Clojure. So enough about me. Like Mark said, I am the maintainer of this open source project called Clips that allows to run pieces of code right into a browser, because in many languages, so in JavaScript, of course, but also in Clojure, in Scheme, Lisp, Lua, Scheme, Python, Ruby, BrainFuck, PHP, and I probably forgot a couple. There are interpreters, JavaScript interpreters to virtually any language beside Java maybe, or Haskell, or very complex languages. But regular languages, let's say, there are interpreters, JavaScript interpreters. So every language could run in the browser, and that's great. And 1.5 years ago, I started to write a book for Manning, and it's called Data-Oriented Programming. And really, it's a journey to write a book. Before I started writing the book, I saw that when someone writes a book, he knows the subject, and he writes the book to teach the subject. And in fact, I discovered that when you write a book, well, when you start to write a book, you want to learn a subject. And in order to write about the subject, you have to learn the subject very, very deeply. At least when you write a conceptual book and not just a manual. If I want to write a manual about Clojure, I don't need, maybe I just need to learn a few edges of the language that I'm not aware of. But if I want to write a conceptual book, like about programming paradigms, or about persistent data structures, or about when the paradigm is relevant or when it is not relevant, or what are the limitations of the paradigm, or how to apply the paradigm in different languages, I really need to learn the subject. And by learning, it's not just learning how to explain, it's really learning. And for me, that's one of the greatest gifts that I've got since I've started to write the book, is that I have understood so many deep things in Clojure and in programming in general. And I hope I made a good job in explaining as in the simplest way, or as simple as I can, to the readers, the things that it took me so long to understand. So that's really fun to write a book. And before writing a book, I had a blog for several years, and I saw that, okay, if I was able to make a popular blog, it will be a piece of cake to write a book. I was totally wrong. It's completely different. Writing a book, it has a beginning, a middle, an end. While when you write a blog post, every blog post is independent, and it's much easier. Having a plan in mind and deciding what I'm going to teach in chapter 6, 7, 10, before you start the book, for me, it was really, really difficult. You know, I was for 20 years, not 20 years, but for 10 years, I worked for agile companies. And in agile, you don't plan 2 years forward. So I was used to plan only one chapter or half of a chapter. And I remember when I started to write the book, I couldn't even plan a chapter. I wanted immediately to code, to write, no planning, just writing. And it was so wrong. It doesn't work, at least for me. And it was quite of an effort to convince myself, my laziness, to plan each chapter and to put the constraints and the boundaries of the content of each chapter. And once I've learned to do that, it became a pleasure. But so much suffering until I got to this pleasure. So anyway, that's the book. I think it's fun to read. At least it's fun to write. So if you're interested, give it a look and tell me what you think about. We can discuss on Twitter or Slack or whatever. So what is, like in the tradition of Clojure talks, I'm going to put a couple of definitions. secret sauce. I said the title of the talk is Data-oriented programming, the secret sauce that makes Clojure program less complex. So what is secret sauce? So secret sauce, for example, in spaghetti, is an element, quality, ability, or practice that makes something or someone successful or distinctive. And what is complexity? Complexity, in the context of this talk, it's not how much time it takes for a program to run, but it's how much brain resources it takes to understand a program. So when I say a program is complex, I mean it's hard to understand. When I say a program is simpler, it means it's easier to understand. And this definition is not mine. It appeared in this very beautiful paper called Out of the Tar Pit. So with that in mind, let's see why data-oriented programming is so distinctive about Clojure and why it makes Clojure programs easier to understand. Okay, so for the folks that are, let's say, with a couple of months in Clojure, you have probably discovered the pillars of Clojure as a programming language. I will go in the clock direction. So pillar number one is that Clojure is a homo-iconic language, which means that the syntax of the language is the same as the syntax of the data in the language. So if you take a piece of Clojure code and you look from really far, you cannot really say if you have code or data because you have parentheses, curly braces, and square brackets. And it's only when you come closer that you add semantics that you could distinguish between code and data. So that's what we call homo-iconic. And it's great because it makes it very natural to extend the language with macros, which is not the case with macros in C, for example. Writing a macro, for example, in C, when you write macros, the macros is its own language. It has nothing to do with C. While in Clojure, when you write a macro, you write a code that receives a list and returns another list. And this is possible because the language is homo-iconic. And another benefit that we get is that if you use paredit or parinfer or stuff like that in the IDE, you can navigate the code or edit the code in a structural way and not only line by line or character by character. You can navigate form by form and manipulate form by form. You can extend a form, you can reduce a form, slur, barf, etc., etc. So that's the benefit of homo-iconic. It comes directly from the Lisp tradition. The second thing about Clojure is that it's a functional programming language. For example, you have so many functions in Clojure core to manipulate data. And the fact that we have so many functions, group by, sort, frequencies, partition all, take while, drop while, take, etc., it increases our power of expression. And this, for example, we have almost the same power in JavaScript, at least if you add third-party libraries like Lodash or Ramda. But in terms of language, JavaScript is almost as rich as Clojure in terms of the power of expression to manipulate data. The third pillar of Clojure is the REPL. Once you get used to it, you get addicted and it becomes really hard to program without a REPL. We are so effective and so productive in the REPL to the extent that some folks say we don't need tests. We don't need to write tests. You write your code, you test it in the REPL, it works, done. I don't know if I agree or disagree, but the idea that you could think about that you have ways to test your code without running a whole program, it's amazing. And it's shortcuts. It gives us a very short feedback loop between what we have in our mind and what happens in the reality. And it makes us very, very productive. And the same when we need to explore code. So when we write code, we have a very short feedback loop. And when we explore code, the REPL also is very handy to test a piece of a function to see what happens if I pass this data, what do I get, etc., etc. And the fourth pillar, and that's the one that I like to focus on today, is data-oriented. And we are going to deep dive into data-oriented. And the main benefit is that it reduces complexity. So I'm going to claim that a program that is data-oriented is easier to understand than a program that is not data-oriented. So let's have a journey, and let me tell you about the history, a brief history of data-oriented programming. When did it start? It started around 1936 with a very smart guy named Alonzo Church, who invented the lambda calculus. Lambda calculus is the theoretical foundation of functional programming. And by the way, in lambda calculus, everything is a function. Even numbers are represented as function. If you have maybe heard about Church numerals, and functions have no names, only anonymous functions, no numbers, only functions, and it's Turing complete. It has the exact same power as any other programming language. 20 or so years later, John McCarthy invented Lisp. And it's amazing how modern this language is until today. If you read the paper about Lisp that John McCarthy wrote, I think in 1960, it feels really modern. It doesn't feel outdated. And one of the great things that came in this language is the distinction between statement and expressions. Back then, in 1958, the other language was Fortran, and in Fortran, everything was a statement. I think that even when you called in Fortran, when you called the function, you didn't get a result. You had only side effects. And also a statement. When you run, for example, when you have an if statement in Java, in C# or JavaScript, the if statement doesn't return anything. It does something, and it's, for example, it sets the value of some variable. And it's much more difficult to manipulate statements than to manipulate functions. And John McCarthy invented the cond statement, that you pass several conditions, and depending on what condition applies, the cond statement would return a value. So the cond expression, so not the cond statement. So that was a revolution then. There is this beautiful paper from 1981, and it's a very easy read, very, very easy read, called Values and Objects in Programming Languages by Bruce McLennan. I really encourage you to read this paper. It's 4 or 5 pages, and it's beautiful. And it makes a clear distinction between what do we mean when we say a value and what do we mean when we say an object. Not object in the sense of object in C++ or Java, but object as something that has a state, and value as something that doesn't have a state. And for example, values are, because they don't have state, they can be easily shared. And objects are much more complicated to share because they have a state. And if you share an object into threads, it's not clear what's going to happen if one thread changes the state of the object. What's going to happen to the second thread? So this guy is really brilliant. It explains in very, very simple words what's the fundamental difference between values and objects. In 2000, there was a breakthrough in the academy. This guy named Phil Bagwell invented a data structure called ideal hash trees, or HAMT, that made it possible 7 years later, when Richie invented Clojure, to have efficient persistent data structures. So the maps that we use in Clojure since 2007, and the fact that we are able to create new versions of the map without mutating in place, it is made possible to be efficient because of this invention in 2000 by Phil Bagwell. Interestingly enough, when Phil Bagwell invented ideal hash trees, he didn't think about persistence at all. His data structure was mutable. And it was the genius of Rich Hickey to discover that this ideal hash trees could be made persistent in an efficient way. And because it's a tree structure with branch 32, it's really efficient to do structural sharing and to create new version of the tree very fast, both in terms of computation and very efficient in terms of memory. So it's a combination of academy and industry, I would say, between Phil Bagwell and Rich Hickey. And in the middle, there was this paper from 2006 that I mentioned a bit earlier, Out of the Tar Pit, where they define what is complexity and why in the software industry, the programs that we made are so complex, so hard to understand, so hard to maintain. And I think that conceptually it had lots of influence on Clojure, the language, and also the Clojure development and the libraries and the ecosystems, etc. Also a good read. Not as easy as this one from 1981, but also a good read. Any questions so far? Comments, ideas, wishes?
When you say persistent, is that referring to the fact that Clojure data structures, you can't, when you create a new Clojure data structure, it shares state with a previous one? Is that what that means?
Yes, yes. So persistent, immutable, shared. Yeah, I'm using them as equivalent terms. Okay, thank you. That's important to clarify. Okay. Let's move on. Oh, and when I prepared this presentation, I read again one of the Lisp papers, not the one from 60, but the one from 68, I think. And in the introduction of the paper, John McCarthy enumerates what makes Lisp stand apart. And it has a lot of parallel with the diagram I showed about Clojure. So I'm going to show you. So John McCarthy, 1979. So 20 years after Lisp was invented, John McCarthy did quite kind of a reflection about the language. And he mentions, so the title are mine, but the text are really from the paper, almost quoted. So one really special thing about Lisp was that you represent information by lists and you do computation with symbolic expressions. Symbolic expressions is like, today we would say JSON or hidden. Back then it was just parentheses with symbols, but it's really the same as JSON or hidden. Representation of information by lists. If you think about a language where there are no literals for data, for example, in Java or C++ or C, or I don't know if it's in C#. And think about what kind of a nightmare it is to even create an array, a nested array. Let's say an array where the first element is an array with 1 and 2, and the second element is an array with 3 and 4. You cannot do that. You have to invoke constructors and types and generics and wow, it's really a burden on our mind. And in JavaScript and in Lisp, you just have notation for data. In the same way that Fortran was good at manipulating numbers, Lisp was good at manipulating data. So that's, in a sense, Lisp was the first data-oriented language. The second thing, obviously, about Lisp is that it fosters the composition of functions using lambda expressions to create functions. It's homoiconic because a Lisp program is represented with rounded parentheses, exactly like Lisp data. And also there is kind of the REPL in Lisp because Lisp itself, actually, if you read the paper from 1958, in the paper itself, where it lays the foundation of the language, I think the paper was written before there was a compiler for Lisp or interpreter. But even then, John McCarthy was smart enough to provide the implementation of the eval function in Lisp. So he not only created the language, he also wrote in its own language on the paper, no compiler, no computer. On the paper, he showed how one could write eval as a Lisp function that receives a form that needed to be eval. So that's really beautiful. And you see, those four foundations are really what we have at the core of a very modern language like Clojure. So that's what I meant when I said a couple of minutes ago that Lisp was really a modern language, even though it's 60-year-old. 60? Yes, 63-year-old, 1958. It's quite amazing. Okay, so that was kind of a long introduction. Now, let's move on into what is really data-oriented programming. So data-oriented programming as a concept is really interesting. On the one hand, if you take an average guy from the Clojure community, let's say with 2 years of Clojure development, 2+ years, and you ask him, what do you think about data-oriented programming? He would say, oh, great, that's amazing. That's the way we should code. On the other hand, if you search on Google data-oriented programming, until January this year, you find nothing. And since January this year, you find either my blog or my book. That's it. No, there is nothing in the internet, in academic papers, in books about data-oriented programming. And it is well known by everybody in the Clojure community. And the reason, or at least I'd like to hear what you guys think, but my understanding is that Clojure itself is so brilliant that it embraces this paradigm, data-oriented programming, and it kind of forces you as a programmer to use the paradigm even without noticing that you are using this paradigm. And that's brilliant, that's great. Because when you program, you don't want to think about programming and theoretical foundation, you just want to be effective in programming. And Clojure really does a good job at it, to the point that nobody until 6 months ago, nobody thought about formalizing what is data-oriented programming. So I took that and even myself, it took me a year of research and discussion with the Clojure community to be able to pinpoint and to formalize what is it in Clojure that is so special and so unique that for me and for others make me so productive and makes it so enjoyable for me to program in Clojure. And I discovered that it is data-oriented programming, and I'm going to nail it down to concrete principles. So it comes down to 3 principles, and each principle is really simple and almost obvious, I would say. And you can look at data programming as one meta principle. Data is a first-class citizen. So what are the 3 principles? Number 1, you separate code from data. So that's a total separation from, not separation, total departure from object-oriented programming, where data is encapsulated into objects with code. So that's principle number 1. Principle number 2 is that you represent data with generic data structure. You are allowed to have data. Let me say it in a different way. You are allowed to manipulate data with generic functions. For example, when you have a hash maps, you can retrieve the keys of the hash map with the generic function named keys. Or you can retrieve the value associated to a key in a map just by passing the name of the key. You cannot do that with class. If you have a class with members, you cannot access a member of the class in a generic way. You have to import the definition of the class, and only then you are allowed to access a member in the class. And that's the foundation of the Clojure core namespace. Because data is represented in a generic way, we could write hundreds of functions that manipulate data. And it works with all maps. It doesn't matter if the map represents a product or a customer or network or whatever, it works. And principle number three is that data is immutable. We don't want to mutate data. And what I like about those principles is that, first of all, they are language agnostic. They come from Clojure, but they are not applicable only in Clojure. And in fact, in the book, I'm spending lots of time to illustrate how one could apply the three principles both in the OO language, in the object-oriented language, and in the FP language, in the functional programming language. Number two, it could be applied in a statically typed language or in a dynamically typed language. Although for principle number two, it's more challenging to represent data with generic data structures in a statically typed language. It's not that it's doable, but it causes lots of friction because developers from statically typed language like Java or C# or Go or C, they love to define at compile time what is the exact shape of data. So it's a cultural challenge. It's not a technological challenge. You could apply the principle in isolation, but when you combine the three of them, you get something very, very powerful. For example, one of the reasons that in object-oriented programming language, they prefer to hide data and to give access to data only through methods, getters, or setters, is because they are afraid that somebody is going to move the cheese. Somebody is going to modify a member of an object and put the object in an invalid state. But if data is immutable, there is nothing to fear of. If my object is valid, it will stay valid forever. If someone wants to create an invalid version of an object, that's his problem, that's not mine. So my state is safe. So we see that there is a synergy between the three principles, and right now I just illustrated the synergy between principle number one and principle number three. Let me see, how do we stand in terms of time? So any questions so far?
So I have a question. When you talk about the 1, 2, and 3 there, I think of like forward chaining rule systems, and they separate, all the representation is in flat data structures, they're tuples, and then the code is represented as rules that manipulate those, and those rules assert and retract facts, right? You could argue those facts are immutable. It's like which facts are present, which ones aren't. That almost checks off all the boxes here, right?
Yes, and I think that's level 2 of data-oriented programming, and I think the proper term for that is data-driven programming.
Okay.
So let me clarify. In data-oriented programming, you represent data as data. Simple. Mm-hmm. In what you mentioned, you represent behavior as data. So it's level 2. First, you have to agree to go through level 1 that data should be represented as data, and then you can move forward and build kind of DSLs or data-driven programs. And obviously, you will use the same principles, and obviously the rules will be immutable. And if you want to change a rule, you will create a different version of the rule, etc., etc.
Yeah, in my master's thesis, I tried to combine an object-oriented language with a rule language like this, and got right in smack in that place where they both completely disagreed about information hiding and abstraction, and the objects wanted to hide their state, and encapsulate it, and the object system, or in the rule system, wanted to expose that state and make it completely flat, make it all available and accessible, and finding a way to get those two to cooperate was my challenge. And I didn't come up with any great answer on that, but I mean, I came up with something, but it was like a multi-paradigm language. You have to either choose to go one way or another in how you use it, like you might see today, in a lot of languages that have libraries that let you do functional programming, but don't require you stay there, right? And so you can use them various ways.
Yeah, it's almost like, if you allow the rules to be mutable, it's almost like you allow your program to rewrite itself, which makes no sense for a regular program, at least.
Right.
Yeah, let me get through what was written on the chat. Yeah, so someone wrote that it should be try and not tree. I agree, but the name of the paper is tree, is ideal hash trees. And in the paper, he talks about tries. Okay, Bagwell. So Dan asked the question, if Bagwell wasn't thinking about immutability, what problem was he trying to solve? That's a great question. And it comes down to something that bothered me when I discovered about hash maps. So when you have a hash map, what is the trick of a hash map? How could you have keys from an infinite spectrum and represent them in a data structure that is with a limited size, right? Think about a hash map where the keys are strings. You have virtually infinite numbers of strings. So how could you represent these maps in a limited size of memory? And the trick is to use a hash function that takes this infinite space of strings and maps it in a pseudo-random way into numbers between 0 and 100, or between 0 and 1,000, or between 0 and 1,000,000, or between 0 and 5, whatever. That's the property of the hash function. But now you have a problem. When your map grows, if you decided that you're going to use a hash function that maps from the infinite space of strings to, let's say, numbers between 0 and 10, that's fine. But when you have 20 entries in your map, you need to change the hash function and increase the size of the array. And that has a performance hit, which is amortized. So it's still O log n, but in practice, it causes problems. And that's the problem that Bagwell's wanted to solve. So Bagwell's trees grow naturally. As it goes, the structure gets bigger and bigger. You don't have to pre-allocate a huge array with holes. And there is a very nice trick that I discovered last week when preparing a chapter of the book about persistent data structures, where Bagwell shows how to represent a sparse array of size 32 without having to pre-allocate an array of size 32 using index bitmap. So I'm going to let you with this cliffhanger effect so that you are motivated to read the book.
Yeah.
So I think we are I think that's a good place to pause and to move to the second part of the meetup. But before that, if there are other questions, I'd be happy to, or reflection or comment or whatever. Anybody wants to share something?
What reaction do you typically get from non-Clojure programmers when you advocate data-oriented programming?
Yeah, that's a great question. That's a great question. In terms of sales, the book does well. The early access it's a successful book. But I don't know if it's because Manning put lots of marketing efforts or because there is really an interest. And I don't know the people that read the book, where do they come from? It could be that all of them are closurists, just enthusiastic about the idea that we're going to change the world. So I don't know. But I can tell you, Java folks are really negative about that. Really, really negative. JavaScript folks are open, very open. In fact, in JavaScript, actually it comes down to what is missing from the language, from those three principles. What comes naturally in the language and what doesn't come naturally in the language. So, and in Java, for example, the three of them are not natural. In Java, it's not natural to separate code from data. It's not natural to represent data with hash maps of string keys and values objects. And it's not natural not to mutate data. So everything is not natural. In JavaScript, it's quite natural to separate code from data. It's natural to represent data with JSON, objects, and arrays. And mutation, it's not very natural. So it's just, you miss just one principle. So you are open to that. I think for statically typed languages, I would be very happy if I can move the nail a bit and open their mind so that it's okay sometimes not to statically type everything. I think for dynamically typed language, it's almost a no-brainer. The only problem that you have is that you need a third-party library that implements efficient immutable data structures. And it's not as easy as it sounds. For example, there is a great library by Facebook called Immutable.js that basically implements Clojure maps and Clojure vectors in JavaScript. And it was developed by Clojure. Clojure developed also React.js. And in React, it makes lots of sense to use persistent data structures. So they developed this library. But because JavaScript objects are not objects, they have no interfaces, it's really hard to make a non-native object pretend that it is an object. You could do that with proxies, but it's very hard to make it work. And now you have a problem. If you use Immutable.js to represent data, then you cannot interact smoothly with other third-party libraries. So it's not as easy as it sounds. I wanted to say something. Yeah, so on the one hand, there are implementations of persistent data structures in every language, Java, JavaScript, Ruby, Python, C#, whatever. On the other hand, it's a challenge to integrate these libraries. Oh, and something very interesting, there is a proposal in ECMAScript, in JavaScript, a proposal that has made it to stage 2, which is quite advanced, for immutable data structures in JavaScript. So in 2, 3, or 4 days, every browser will provide a native implementation of persistent data structures. And then we will need to ask ourselves, why do we need Clojure?
Well, we still got the REPL and homoiconicity.
Yeah.
We have a nice diagram to show them.
Yes. I'm half kidding. But really, I think it's in a sense, it's Clojure curse.
It's probably more of the Clojure script than the Clojure, right?
Yeah, Clojure script. I mean, when you promote important ideas, people take them and implement them in their own language, and then maybe they don't need you. That's kind of a trade-off. I mean, you could influence the humanity, but everybody will forget that you were the one that invented. Or you could take all the credit for you and what else could I share? Yeah, there are also, let me just mention things in Clojure that you might have encountered and didn't notice how it connects to data-oriented programming. For example, atoms. So atoms in Clojure, they provide basically two methods, one called reset and one called swap. Reset is really simple. You just modify the current state of the atom. But swap is more interesting because what do you do with swap? You take a snapshot, you take the present value of an atom, and then you compute the next value of the atom. And then when the computation is done, you reset the atom to the result of the computation. But what could happen is that during the time it took you to compute the next version of the state, someone else in another thread changed the state of the atom. And so now your computation might be inaccurate because you base the computation of a previous version of the atom. And in Clojure, the way they solve it is that when you start the computation, you keep in the left hand the previous value of the atom. And before applying the next value and to be the next state, you compare, you check whether the state have moved forward or not. And you have to do it atomically with a function called compare and swap. You cannot do that with no support of the operating system. But what's interesting is that because data is immutable, you need to compare only the references. You don't need to compare deeply every leaf of the value. So even if you have a huge nested map with thousands or millions of leaves, you just need to compare the references. And that's why swap is fast, is efficient. So swap relies on CAS, on compare and swap, and it relies also on immutability for fast equality check by reference.
So question about Java and data orientation. Has no one tried to implement the persistent data structures from out of the tar pit in Java? I mean, Java has made some moves towards functionality with lambdas and other modernizations. So yes. I'm just wondering if it's really a hopeless thing to ever do data orientation well in Java, or is there a path?
So someone, I don't know, I can tell you what people told me. So people told me that if you, Yehonathan, find a way to make Java programming simpler, people are going to kill you because there's so many consultants and consultant agencies that rely on the fact that it's very hard to write and read Java programs, that if you find a way to make it easier, it will be, the economic consequences will be dramatic. So nobody will let you do that. So the Java ecosystem, Java as an ecosystem has no incentive to get simpler.
That's fine.
I think you mean it's enterprise grade.
What?
It's enterprise grade.
Yes, exactly. So, but on the other hand, in Java, I don't remember what number, 13 or 11 or something, there is support for immutable objects.
That's right.
Records, Java records, in Java 11, I think. But it's only for objects, and it will work only when you have low numbers of members. There is no tricks, there is no smart implementation, there is no Bagwell there. And when you need to create a new version of an object, you copy all the members by reference. So it's naive structural sharing, and it works because in an object you don't have millions of members, right? In an object, how many members could you have in an object? 10, 20, 50, that's it. And number 3, back to your question, Mark, there are implementations of persistent data structures in Java. There is Paguro, by Glenn Peterson. There is Bifurcan by Zach Tellman, a great Clojurist. And there is something called P collections by, I forgot its name. And some of the implementations are even more efficient than the Clojure ones, because Clojure implementation of persistent data structure is not perfect. It could be improved. And those folks have made some improvements. But it's one thing to provide the code that does something, and it's another thing to convince the community to use those libraries. So those libraries are not well known in the Java community. But the code is there, and in my book, I am advocating to use those libraries to make your code simpler. And it's interesting. Another thing I want to tell you and to think about: if you say to someone, we use immutable data to write our programs. So the reaction will be, yes, it works well when you do math, right? If you need to compute sinus or cosinus or x squared, etc., or solve riddles, it works well. But for the real stuff, for programs with states and database and whatever, it won't work, because you need mutation. I mean, right. Objects have a state, and the state is a function of the time, and at a different point of time, the state has different values. And actually what I discovered is that Clojure value proposition is that it's simpler to manage state with immutable data structures, because then you have a clear separation between the object, the state, and the value of the state at some point in time. And the value of the state at some point in time is immutable. While in regular Java, the two concepts are conflated into objects. You cannot take snapshot of an object in Java. There is no such concept. It's almost like, I don't know, the body and the soul, if you want. You cannot take a snapshot of your body, but it would be very useful. Let's say I want to do a cancer diagnostic, something like that. It would be very nice to do a snapshot of my body, to send a snapshot to the hospital, and I can continue to live, and I get the answer when I get the answer, right? And because it's not possible in the real life, we have to go to the hospital and to wait and to be stressed, etc., etc., etc. So in a sense, what Clojure as a concept brings us is this great insight that we should clearly separate between state and value of the state at some point. So it's not only that it's possible to manage state with immutable data, with immutable values. Is that the best way to manage state, at least according to Clojure? And Clojure intent is not to solve mathematical riddles. Clojure intent is to solve production issues and to write real systems. And that's where it differs, I think, a bit from Haskell and all the purely functional programming language. Clojure is a pragmatic functional programming language. It's not a theoretical programming functional programming language. And it's not purely functional. Did it answer your question, Mark? About Java, you asked about Java.
Yeah. I guess it's useful. I mean, for me, the first aspect of Clojure that really jumped out at me in terms of its handling of data was the fact that you could express all the basic collection types without any ceremony at all. That is, you type a map or a set or a vector, right into your program. You don't have to, add it to a list with function calls. Everything was explicit. And so that's one piece of the puzzle, I think a really valuable one, but as you've pointed out, there's a lot more that's necessary to really embody the full philosophy of data orientation,
And
not just
what's interesting,
what's it
and
saying.
yeah, and I come back to the question that Jeremy asked a moment ago. In Clojure, if you have followed over the last, I don't know, 3 or 4 years, there have been a movement into typing or schema or specifications.
Right.
And the way I see it is not that typing is bad or let people do their mess how they want. No schema at all. We should be free. No, it's not that. It's that we don't want to couple between data and schema. We want the freedom to decide what pieces of data I want to spec and what pieces of data I don't care to spec, and it will be a burden to spec. And I think that right now in 2021, the language that handles in the best way this trade-off is TypeScript, not Java. TypeScript. TypeScript is a beautiful language by Microsoft. It's really amazing. And I discovered TypeScript because one of the readers of the book told me, hey, you are advocating something that in TypeScript is already there, and even in a better way, that's the way you advocate. And TypeScript gives you type a la carte. So in a TypeScript program, you are allowed to type what pieces of program that you want. You don't have to type everything. You type what you want. And you could even say, here I have a map where the key should be ID and the value could be whatever, I don't care. So it gives you very lots of granularity and freedom. And it shouldn't be a surprise that the authors of Mali, if you guys know about Mali, which is like spec version by the community, took inspiration from TypeScript.
I think TypeScript has made a good separation. They're more duck typing, right? I mean, they really allow you to use typing as a shape, like we might think of as a shape, as opposed to Java, which uses it to structure code, which is very much more restrictive, right? But I think grasping on to the concept of duck typing doesn't meet this minimal requirement, even though it's something much more than that, I think is hitting the sweet spot, right?
Yes.
What do you think of core.typed?
I don't know. I've never looked at it.
Okay.
But TypeScript is really, if you want to play, and the Microsoft tutorial, online tutorial, is really, really amazing. And the amount of tooling that they give you, also, it's Microsoft. They put an army of developers, so they have. But it's really inspiring, I think. And I would expect that in the same way that after 10 years, the Clojure community acknowledged, and even the Clojure core team, that we need sometimes to put boundaries of strictness when it makes sense, for example, at the boundaries of the system. So we embrace typing, and we embrace typing in a way that it's even more powerful than static typing, because we could do validation at runtime. We could say, I want a map where the value is ID and the key is ID and the value is a number between 5 and 10. You cannot do that in Java. So we do typing better than statically typed language. I would expect that statically typed language would also go toward us and say, we should find ways to allow you not to type. So by default, you type everything. But if you want to have let's say an object with a member ID and the value whatever, you should be allowed to do that and not have to declare the value as an object and do statically casting, or I don't know. I think that it will go this way, where there will be less of a war between who is right, statically typed language or dynamically typed language. There will be each family of language will learn from the others and find the sweet spot. And then, depending on your application, you will choose what is your default. would you prefer to start from dynamic and a la carte type, or start from static and a la carte be dynamic?
So another aspect of Clojure's data representations that really blew my mind was the fact that you can have truly arbitrarily nested heterogeneous collections. You can have sets as a key in your map. You can have vectors that contain maps that contain sets. It's really amazing when you're coming from other languages where a vector can only have a single data type within it to something that's completely freeform. And that is incredibly freeing. I don't know if, does that exist in other languages, or is that unique to Lisp and Clojure?
So I think that every question that contains the word does that exist and JavaScript, the answer is yes. So in JavaScript, they have maps. So the curly braces in JavaScript, they call it objects.
Right.
And in objects, the keys must be strings. But there is another construct called map that you create with the constructor.
Okay.
And then the keys could be anything.
Interesting.
It's not only strings. It comes down to homogeneous map and heterogeneous maps. And if you read the paper by Rich Hickey, The History of Clojure, you will see that he asked himself whether he should provide two different kinds of maps. Because records, what we call heterogeneous maps, and heterogeneous map, usually it's a low number of fields, right? In a record, you don't have thousands of fields because you have to specify them a priori.
Right.
So, and you have the other things, which is homogeneous maps that could grow infinitely. For example, if you do caching, or if you want to represent all your users, a map with all your users and in the value, I don't know, the average spending, something like that. So it could grow and grow and grow and grow. So it's interesting. Homogeneous maps could grow, but they're homogeneous. Heterogeneous maps, usually they don't grow, but they are heterogeneous. And he mentioned that he asked himself whether there should be two different literals, because it's different use cases. And the fact that Brendan Eich in 1995, when he invented JavaScript, decided to use one literal both for maps and for record, and Rich Hickey also, is quite interesting.
Huh.
And another thing also that I discovered while writing the book, for records, you don't need persistent data structures. You don't need Phil Bagwell. Can somebody see why?
Oh, thanks for that.
Isn't it interesting as a claim?
Well,
So
I'll let other people.
let me prove that to you. Again, when I say a record, I mean a map with, let's say, up to 20 members. So if you have a map with up to 20 members, and each member, let's say, is also a map with 20 members and nested and nested and nested, no matter how many levels of nesting, you could do structural sharing very naively. So let's say you have this huge tree, and now you want to change one value, like assoc in Clojure. You want to take one value down the tree and create a new record where this value has been changed. What you could do is what is called structural sharing or path copying. You copy all the value at each level, but you do shallow copy. So you do 20 copies at the first level. And you share 19 nodes, and only the one that you want to change, this one you change, and the same again at each level. And it will be very efficient. It will take you, I don't know, 80 copies. So it will be almost as fast as persistent data structures. So when persistent data structures are important, when you have homogeneous maps that could grow in thousands or millions of keys. And I think that we should all be thankful to Rich Hickey for taking care of this use case in 2007. It would have made much more sense for him to be lazy and to say, why should I care? Why should I care about what happens when a map has thousands of entries? Usually maps have a slow number of entries. I don't care. But no, he wanted to create a language with solid foundation that will not break when it scales.
Right. It goes right to your simplicity observation.
Sorry?
You shouldn't have to worry about, those details.
Yes, exactly. You shouldn't have to worry. And he spent, I don't know, 3 or 4 months of research and implementation to find this Bagwell trick and implement it. It was not off the shelf. But he really wanted to prove something, that it could be done with no, star like in a contract. Yeah, it works until it breaks.
We tell a lot of the developers in that I work with that are building platform or libraries that they need to do the hard work so that the consumers of their stuff, it makes their life easier, because there's a whole lot more than there are of you, right? If you're successful. And I think that's key. And I think thinking and doing it the hard way so that it does make that conceptually simpler and scalable it's a hard decision, because everyone wants to do the quickest, cheapest thing. But that's the wise way to have longevity.
Yes.
Yep. Good judgment. All right, so we could have some more Q&A, or if at some point, if you want to talk about the wiki, what would you like to do next?
I think I am a bit tired. It's almost 10:30 p.m. here, so I need to rest.
Would you like to talk about the wiki and point?
Yeah, maybe let me give a short introduction about the wiki. So recently I have re-listened to a couple of Rich Hickey's talks, which is always a good thing to do. Just a second, I need to. And I have, I don't know for you, but on the one hand, when I listen to Rich Hickey, I feel really illuminated. Wow, amazing, beautiful. But on the other hand, when I try to explain to somebody else what I listen, it's very difficult for me, because he talks at a very abstract level or very high level. So when you listen to him, it's convincing, but it's almost like magic. And the way, at least for me, to internalize what he says is to rephrase and to reformulate or to give concrete examples. That's for me. I don't know for you. So what I decided to do is to put on a GitHub repository wiki pages with 3, 4, 5, 6, 7, 8, 9 basic concepts of programming that has nothing to do with Clojure, but Clojure philosophy lays on an interpretation of those concepts. And if you agree with the interpretation, then it makes a lot of sense to go the Clojure way. So, and it's a work in progress. So as you will see in a moment, each concept links to a wiki page, and it's really short. And if you are okay, guys, I would be very happy if you could contribute. Pick one of those terms and contribute and give more example and reformulate and make it clearer and more concrete. Because we could disagree or agree about should the language be statically typed by default or dynamically typed or generic? Or that's an interesting debate to have. But I think the even more interesting is to go one level above and to think in general about programming, what makes sense. And even if we decide not to do the best thing, it will be as a compromise. And at least we know what we trade for. So Mark, pick one term from this list and I will go and illustrate one of the concepts. There's no order. The order is alphabetic. So, and they are all intertwined and connect one to each other. So we could start from wherever you want.
Well, the one that intrigues me is maybe. That
Okay.
always associates in my mind the maybe monad, but I have no idea if that's what's going on here.
Okay, maybe. So as you might expect, there is a surprise. Nothing is of type maybe. That's a famous Richie Key claim. He has a talk called Maybe Not, I think.
All right.
Yeah.
But
Yeah.
even before this talk, so again, that's something about maybe the monad. I don't know the maybe monad, but I know that in Java it's really complex to deal with something that may be here or may not be here, and you never know. And nillable, non-nillable, and it's complicated. So what he, okay, I'm going to stop quoting it. I'm going to say my understanding. Okay. So what I understand is that maybe it's not about the type, it's not about the thing. Okay. Maybe is a property of the aggregate, not of the field. For example, in a record, some field may be here or may not be here. It's not a property of the field, it's a property of the aggregate. Okay, let's take an example. The social security number of a person. Would you say it is maybe a string? No, it's a string. But what you could say is that for a person, I may have his or her social security number or not. So it's a property of an aggregate. It's a property of the person or the representation of the person inside the program.
So in C#, there's like a question mark suffix they put on record access, right? That implements this with that same concept. It may or may not be there.
Yes, exactly. So what's important is it's not a property of the field. And again, it has nothing to do with Clojure or any language. It's a conceptual claim that maybe it's not a property of a field. You cannot say that social security number is maybe a string. Social security number is a string. It may be there or it may not be there. Okay, let's go one step further in case it's too simple. Now let's be more precise. I'm going to read this piece. Actually, it's not really a property of the aggregate, but it's a constraint or not on my function. So I could write a function that expects to receive a map that represents a person. And now I can say that my function will work even if the aggregate that it receives has maybe a string for the social security number. Or I could say, no, my function will work only if the social security number is there for sure. So it's not the property of the aggregate. It's not that the person may have or may not have a social security number, is whether my function knows to handle situation where the map that represents a person doesn't have information about some field, like social security number. So for example, we could, I think there are three kinds of functions. Functions that require the presence of the field. For example, if I write a tax-related function, if I don't have the social security number, the function will not work. And it's up to me to verify upfront that when I call the function, I pass it a record with the social security number. There are functions that don't care. For example, if I have a function that calculates the full name of a person, I don't care about the social security number. It doesn't make any difference. It could be there or not. It has no influence on the behavior of the function. And there is a third kind of functions that behave differently depending on whether the field is here or not. For example, a function that serializes the person data. So if the social security number is here in the resulting string, the social security number will be there. And if there is no social security number, the social security number will not be there. So the behavior is different. And by that, I wanted to illustrate that it's a property of the function, not of the field, and even not of the aggregate. And that's the case for, again, decoupling between the code and the schema about the function. So for example, in spec or in Mali, I would write my function, any of the three, and then in a different place, I would say, okay, the function foo need to receive the map that has a field social security number that may be a string. And the function bar needs to receive a map that has a social security number for sure. And the function foos doesn't care about whether the field is here or not. So you see that it's a property of the code. It's not the property of data. It's in the relationship between code and data. So as you see, this is very tense, and I'm sure that it's not very clear. And I'm sure that if someone reads that in the middle of nowhere, he will not understand anything. So feel free to, I'm going to send the link to this wiki. Feel free to improve. I will not be offended. I will be very happy. And what's interesting is I think this kind of claims could trigger really interesting conversation. And I'm sure that someone that think in Haskell will have a counter argument and say, no, it's a property of the field or whatever. And it could bring very interesting philosophical discussion or conceptual discussion.
You know, it'd be really interesting to take something like, you know, Robert Martin, you know, Uncle Bob. If you take his clean code book, like it's a classic, right? And a lot of engineers learn a lot from that book. To take his point by points, and in the end, he has a set of rules that he follows that he pulls out of this. But to take that and use, you know, layer that against this and say, what's the response here in the data-oriented world? When he was focused mostly on object-oriented in that book.
Yes.
But that would be really interesting to like overlay and intermix those two and use that to drive conversation.
Yes, I totally agree.
Yeah, very much. It's often interesting to see how well Clojure embodies best practices that in other languages has to be done by convention. For example, design patterns, the Gang of 7 or Gang of 4 design patterns, you know, 2/3 of those disappear in functional programming languages because they're not needed. They're, you know, they're really a crutch when you don't have a powerful enough language.
You know, we might even be able to get Uncle Bob to contribute here because he's written blogs since that book where he's clearly a Clojure advocate.
Yeah, we should give him a shout.
Yeah, one of my mentor at Manning is a Java folks for long, and he has written a couple of books, successful books in Java. And he told me that he has lost his motivation for writing a new edition of the book after talking to me and to Eric Normand about functional programming and data of the program, because suddenly it makes no sense for him to continue writing in Java.
Wow, that's a tough one, but
Yeah.
I can definitely see that happening.
Yeah.
All right.
If you can take one thing from this conversation, it will be to thank God or life or universe or whoever you want to thank for writing in Clojure and not in Java.
Yes. definitely feel that way.
Amen.
All right.
Yeah.
So do you want to look at any other these or is that?
I'm really exhausted. It would have been a pleasure, but I'm really exhausted.
Okay.
And I leave up to the community. Please take one of those and improve. The community of developers need you.
If we want to talk about this with you, is Zulip or Slack the best way to reach you?
Slack, yeah, Twitter, or I could write my email. I have no secret. Yeah, please share whatever you discover or insights or thoughts. Really happy to hear and to start a discussion.
Cool.
All right. Well,
Thank you so much. This was super interesting.
yes, absolutely. Appreciate it. And thanks to everyone for attending.